Hi, I am Deepak and my teammate is Parmala. Our project is explaining a genre, interpretable music genre classification using CNN and spectrogram analysis. Music is often described as a universal language, yet the ways we characterize it into genre like rock, hip hop, folk, and electronic involve incredible subtle patterns in rhythm, tone, and instrumentation. As humans, we naturally pick up on these differences, but the question we ask is, can a machine learn to do the same? This is an important problem, especially today when platforms like Spotify, YouTube, and Apple Music deal with millions of songs and need to organize them quickly and accurately for recommendation, playlist, and discovery. Manual labeling is simple, not practical. It is slow, costly, and subjective. Earlier approaches tried to solve this by extracting handcrafted audio features like tempo or rhythm statistics, but they often miss the deeper, more abstract qualities of music. Some methods use pre-trained modules built for images, but these weren't fully optimized for the complexities of musical sound. And even the best models today mostly stop at giving a prediction without providing any explanation of why a particular song was classified a certain way. This lack of interpretability creates challenges in trusting AI systems for music applications. So we decided to work on a system that not only classifies the genre of a song, but also explains its reasoning in plain language, making AI decisions more transparent and easier for everyone to understand. Our approach stands by taking a 30 seconds audio clip from FMA small dataset, which covers 8 diverse genres: electronic, experimental, folk, hip hop, instrumental, and international pop and rock. Instead of using raw audio directly, we transform each clip into a MEL spectrogram, which is a visual representation of how sound frequencies evolve over time. You can think of it like tuning music into an image that captures patterns of pitch rhythm. Then we feed the spectrogram images into a custom-built convolutional neural networks, a CNN model that we design entirely from scratch without using any predefined architectures. My teammate Parmula will be explaining further about the model.
While
While
training
training
the
the
CNN
CNN
model,
model, we
we
took
took
several.
several key steps to strengthen our model. We applied data augmentation techniques like random time masking and wrapping so that the model would not memorize trivial details but learn the underlying structure of music. We used dynamic learning rate scheduling, where the learning rate gradually decreases during training, helping the model fine tune itself as it got closer to convergence. We also incorporated early stopping, so if the validation performance stopped improving, we would avoid overfitting and save the best version of our model automatically. To handle the imbalance in genre representation, we computed class weights and applied them during training to ensure that less common genres were treated fairly. Finally, after the model predicts a genre, we use language model to generate a simple natural language explanation that tells us why the song was classified into that genre using cues like rhythm, instrumentation, or vocal styles. Coming to our results, our custom CNN achieved a test accuracy of around 53%, which is a solid improvement over random guessing. Some genres were easy to classify, like hip hop, where the model achieved a F1 score around 0.73. Similarly, genres like international music also perform quite well. However, some genres like pop were trickier. Pop music often blends characteristics from other styles, making it harder even for humans to pin down sometimes. So it's not surprising that the model found it a bit confusing. On the poster, we have included a bar plot that shows F1 scores for each genre clearly. This visual highlights that while a system works impressively for genres with strong distinctive features, it still has room to grow when it comes to more ambiguous categories. Another key insight was that natural language explanation generated by the LLM added a new whole layer of trust. Instead of just predicting the rock, the system could explain that the dominant use of electric guitar and high energy beats suggests that the track is rock, helping users understanding the model reasoning without needing any technical background. In conclusion, this project demonstrates that the music genres can be effectively classified visually, and looking ahead, there are several opportunities for future work. We could redefine the model further to improve performance on harder to classify genres like pop, perhaps by using larger or more diverse data sets. Thank you.
Thank you.